everybody, and welcome back to the screencast. This is the third episode in the series, and so far we've installed Symfony and we've had a very basic look at routes and controllers. In this episode we'll be taking a look at the Symfony security component and how we can use the Maker bundle to create a login form for users. But before we get onto that, as is becoming our tradition, we're going to start the episode by having a look at Git status. Now, if you've been following along, you'll remember that last time we created a controller using the Maker bundle. So if we run Git status, we can see the controller and the twig template file that was created. You may also remember that we removed the index root configuration from routes.yaml in preference of using the recommended approach of a root annotation in the doc block above our controller method, which we can see here. Now let's go ahead and add all of these changes to Git, and we'll commit those with the message add a default controller and template. Great. Well, let's move on and take a look at the security component. Now, depending on the requirements of the particular project you're working on, you may have no need for authenticating anyone or anything. If all of your resources, all of your pages, all of your data should be openly available, then great. You probably have no need of the Symfony security component. But if, on the other hand, you want to restrict access to some or all of your resources, or you want to control what can and cannot be done by certain systems or users, then you're going to be using at least some of the security component. Now, if you watched episode 1 of this series, you may recall that I installed Symfony using the website skeleton recipe. So I already have the security bundle and security component installed. Actually, in fact, the security component is split into 4 subcomponents, and we can see them here in my vendor directory. Now, on the other hand, if I'd have installed Symfony using the skeleton recipe, I'd need to install the security component separately. And that can be done with Symfony Flex by simply running composer require security, with security being an alias for a Flex recipe, which will install the security bundle. It'll install all of the security subcomponents and all of the associated dependencies. Now, as I say, depending on your project requirements, you may not need the security component, but if you do, it may be that you don't need all 4 subcomponents. You'll certainly need security core, because that's used by each of the other subcomponents and it provides the core security functionality and features. But then the security CSRF, and this will enable you to add protection from cross-site request forgery to your application. There's security guard. This enables you to use or even blend together multiple layers of authentication. And it also has the security HTTP subcomponent as a dependency. And lastly, security HTTP itself is the glue between security core and the handling of HTTP requests and responses. Now, just to mention at this point, in previous versions of Symfony, there was another security subcomponent called security ACL. Now, ACL stands for Access Control List. And Access Control List is a security mechanism whereby access to a resource, more specifically what operations a user or system can perform on a resource, is either granted or denied based on a list associated with the resource itself. So, for example, you may have a resource that can be read by all users, but only updated or deleted by a subset of users. Now, the ACL component was removed in Symfony 4.0 with the recommendation being to use security voters instead. and we'll take a look at those in a future episode. Now, there is, however, a Symfony ACL bundle that works with Symfony 5 if you do wish to use it, but we won't be covering that bundle in this series. And one other thing to mention is that security is changing in Symfony. In version 5.1, a new experimental authenticator-based security system was introduced, which is largely backwards compatible with the current security system. Now, it's not enabled by default, so if you wish to have a play with it, you can enable it in your security.yaml file, which lives inside the packages directory, which is inside the config directory. And you'd add enable _ authenticator _ manager : true. We'll perhaps take a look at that at some point in the series. Right, so let's recap on a typical web application user journey. Let's say that we have a requirement that visitors to our web application can create an account specifying an email address and a password, and then having done so, they can proceed to log in, and on providing the correct credentials, of course, will be directed to a user dashboard of sorts. Let's also add a requirement that the user dashboard should not be accessible to anonymous users. Now, we won't build all of this today. There's a lot to the security component, so let's just take the dashboard and a very simple login form for starters. Now, in episode 2, we created a default controller for our homepage using the Maker bundle. So let's quickly create a dashboard controller and template so that we have that route and a different page to our homepage to work with. I'll quickly do that now. Now, with that done, we can visit /dashboard. This is where we'll display some user-related data in future episodes, but for now, that'll do. We've got our home page and we have a dashboard page. Now, we said we wanted the dashboard to only be accessible to authenticated users. I'm currently authenticated as an anonymous user. We can see that here in the Symfony profiler. Now, I haven't provided any credentials to Symfony, and Symfony doesn't know my identity, and so I am anonymous. We can also see that there's something called an anonymous token and a firewall. That sounds dramatic. So what's going on here? Well, to understand, let's take a look at the security configuration that Symfony created for us during installation. And we'll find it in the security.yaml file within the packages directory inside of the config directory. Now, let's skip over the providers block for just a moment and take a look at the firewalls entry here. Now, the term firewall hails from the construction industry and refers to a type of wall designed to prevent the spread of fire. Now, in computing, the term was adopted to describe a barrier between systems, a barrier that allows the free and unhindered passage of legitimate traffic whilst preventing unwanted traffic. Now, in Symfony, we're able to place a barrier, a firewall, between incoming requests and parts or all of our application. And in the firewall configuration block, we can specify which methods of authentication are enabled for which firewall. So we can effectively say that for users to gain access to one part of our application, they must provide a username and password via a HTML form, but for some other part of our application that's perhaps accessed by an API client, that client must provide a token in order to make requests and receive data. Now, Symfony ships with some built-in authentication providers, and each provider provides a different method of authentication. Now, these are documented here, and the advice is to use these built-in providers if they match your requirements exactly. But if you need a little bit more flexibility, you can use something called guard authentication, and that's what we'll be using today, so we can see how that works a little later on. Now, just to point out, guard authentication is going to be replaced by that new authenticator-based security system I mentioned earlier in Symfony 6.0. So then, how do these firewalls actually work? Well, when a Symfony application receives a request, each firewall configured here decides whether it's going to get involved with the request using something called a request matcher. The request matcher can match a request on a number of different things. The request path is the default method of matching, and you can tell that that's how the dev firewall is configured because of the pattern configuration here. Pattern means match on path. And this is the means by which a firewall expresses interest in requests with a pattern. An incoming request with a path that matches this regular expression will be handled by this firewall. Otherwise, the request will pass through and be caught by the main firewall. Now, you can configure a firewall to match requests on host, on the port, by HTTP method. In fact, you can match requests on any combination of these if you wish. And if you can't achieve what you need to, you can create your own request matcher service. Now, it must implement the request matcher interface, and you set it on the firewall using the request_matcher key, and the value would be the name of the service of your request matcher. A firewall without a pattern, such as the main firewall, will match requests that haven't already been matched by a preceding firewall within the firewall's configuration block. And so with the configuration we have here, a request for the Symfony profiler will be handled by the dev firewall, whilst all other requests will fall through to the main firewall. The dev firewall disables security by setting security to false. And the default configuration is actually true. So if there's no security entry specified within a block of firewall configuration, it means that security is enabled for that particular firewall. Now, although it's best practice to stick to one firewall, you can create as many firewalls as your application needs. And the first firewall that has a pattern matching the request will get involved in that request, and all firewalls following will be ignored. Now, we saw earlier that I was authenticated as an anonymous user, and it's this configuration entry right here that triggers that functionality, anonymous true. Now, for a firewall to exist and impose security, it must have at least one method of authentication. And internally, Symfony creates and uses something called a security token to represent authentication. Now, if there's no other authentication provider enabled, and consequently the user isn't logged in, then anonymous true will cause Symfony to create an anonymous security token. It's simply Symfony's way of recognizing the fact that it doesn't know who the user is. The lazy true configuration here supersedes the old anonymous lazy entry, which was introduced in Symfony 5.1, and that just prevents a session from being started if there's no need for one. In other words, if a response can be returned without the need to check the privileges of the user, then Symfony won't start a session. The user provider entry enables us to let Symfony know where our users are. Now, in reality, a user provider does a little bit more than that, but essentially it enables us to say where Symfony should look for and load users from. We'll talk more about that and see this in action in just a few moments. Now, there's an awful lot to authentication, but let's move on to authorization and back to our dashboard. Now, you may remember we said we wanted to prevent access to this resource unless the user was logged in. Now, there are of course a couple of ways of achieving this. We could turn on access control in our security YAML file, or we could put some code in our dashboard controller. Let's take a look. So let's see how we do this in the controller itself. There's actually two ways. We can add this deny access unless granted role_user right at the top of the controller method. Now, role user is the role that Symfony gives to every user who has authenticated. So if we refresh the page, we get a 401 unauthorized exception, which is exactly what we'd expect, as we've not configured any means by which a user can authenticate. Now, typically at this point, we'd redirect them to a login form, and we'll see that in action in a moment. Now, the other way to do this in the controller is to use the isGranted annotation provided by the Sensio Framework Extra Bundle. Let's remove deny access unless granted, and in the doc block above our controller class method, let's add isGranted role user. Now you can see that that's imported the isGranted class for me. You may have to do that if your IDE doesn't. So let's refresh the page and we should see a 401 unauthorized exception again, which we do. So that's how we do it in the controller. Let's see how we do it in security.yaml. Now down here we can see we already have some examples. So all we need to do is add path, and the path that starts with /dashboard role user. And this will do the same thing, or very nearly. One important thing to understand here is the subtle difference between these approaches. Now, by adding the configuration here, we're matching all routes that begin with /dashboard, whereas in the controller, we were specifically adding the check to just /dashboard. Now you can, if you want, add the isGranted annotation to the dashboard controller class itself. And when you do that, the check is applied to all methods in that class that have the root annotation, no matter what those routes are, regardless of whether they begin with /dashboard or not. Once again, if we refresh the dashboard page, we get our 401 unauthorized response. And that's the response typically when authentication is required to access a resource. So that's all good so far. Now we should be able to access our home page because we've done nothing that should have affected that. Let's check. And yes, we can. Now, given that we want visitors to be able to create accounts and that those accounts will consist of at least an email address and a password, we're going to need to have a user type thing, something which is capable of representing a user. Now, a class seems like a good candidate for the job, and helpfully the Maker Bundle is able to create a user class for us. In addition to our user class, we're also going to need a user provider, something that we mentioned earlier, something that's capable of providing the user or loading the user from somewhere. Now, typically that somewhere is a database associated with your application, but it may not always be the case. You may have Active Directory in the mix or some other federated identity provider system in play. I mean, ultimately, it doesn't matter. The user provider is the thing that's responsible for looking up and loading the user in the first instance, and then on subsequent requests, when the user is loaded from the session, the user provider is also responsible for refreshing the data in the user object. Now, there are a number of different ways we could go at this point, and I really want to keep things as simple as possible and build out from there. So let's create the most basic user class and user provider that we can without getting into the weeds of setting up a database. We're going to need to do that in the future, but for now, let's just keep things simple. So make a bundle, make me a user. So the make user command is an interactive command, although you can provide it the one argument it takes and pass options. It'll guide you through the process of creating the classes and modifying configuration based on the responses you give to the questions it asks. So let's see how it works. So php bin /console make :user. Now the first thing the command needs to know is the name of the user class to create. So let's go with the default of user and hit return. Next question. Now for simplicity, let's respond no. So now the command needs to know what will be the unique property by which a user is known, and we're going to use the default value of email. We'll say yes to hashing and checking of passwords, as that's part of our requirements. Okay, that's done. Let's take a look at the files that have been modified and the new files that have been created for us as a result of running that command. In config packages security.yaml, we can see the command has added the user password hashing configuration for us, and it defaults to auto, which means Symfony will use the best password hashing available on the server where you're running the application. Now it will attempt to use libsodium if it's installed, otherwise it'll fall back to bcrypt. We can also see that the user provider that we'll take a look at in a moment has been added under the provider's entry, and that it's referenced in our main application firewall. We can also see that the command has created the user class for us in the src security directory, and we can see that that class implements the user interface, and this ensures that the methods that the security component expects are present. And finally, the command created the user provider, which we'll need to finish off. So let's take a look at what we need to do. So I mentioned earlier, one of the main responsibilities of the user provider is to load a user. So let's do that. The load user by username method receives the username as an argument, and this is the unique value by which a user is identified. And if you remember, we said earlier that we would be using email addresses for that, and that's what we used in the make a bundle command. So this is where you'd implement your code to look up and load a user. Now, for the purposes of keeping things simple, let's just check for a known email address of chris@example.com. And if that's what we get passed to us in this method, we'll create and return a new instance of the user class we just looked at. So let's get to it and add some code. If username is chris@example.com, then we're going to return a new user with the email address of chris@example.com. Now, because we said yes to hashing and checking of passwords earlier, we'll need to set a password on the user object as well. The security component provides the user password encoder interface, and without getting too much into dependency injection at this point, we can add a type hinted parameter to our class constructor. And if you have auto-wire set true, which is the default in your application services configuration, which is in config/services.yaml, Symfony will automatically inject the correct service based on that type hint. So we can use that service to encode a password and set it on our user. let's take a look at how we do that. So if we create a private property called user password encoder and add a constructor, and we'll type hint the user password encoder interface, and we will set this user password encoder equals user password encoder. Now, as always, if your IDE doesn't import these classes for you, you'll need to do that. And now we can alter the code in our load by username method to return a user with an encoded password. So let's add a line here. User set password, this user password encoder, encode password, and then we have to pass the user object itself in to the encode password method, and then the password in plain text, and we'll just use let me in. And then we return the user. Now, if we get a username we don't recognize, we're going to need to handle that. And for that, we can simply throw a username not found exception. So that covers loading and returning a user object. Now, the other responsibility of the user provider, as we've said, is the refreshing of the data in the user object when on subsequent requests the user is loaded from the session. Now at this point you may want to reload the user from the database and populate certain properties on the user object. But for now, for this example, in the refresh user method, all we need to do is return the user object passed to us, so return user. Now that's great, that's our user provider complete. Now the last piece in the jigsaw puzzle that we need today is the guard authenticator. And by now you should know the Maker Bundle is able to create this for us. And in fact, it'll not only create the authenticator for us, it'll also create a login form. So let's do that now. PHP bin console make auth. Now again, make auth is an interactive command. There are two options. The command can create an empty authenticator for us, and if we choose this option, we'll get a class populated with all of the necessary methods with empty method bodies, and we would need to fill those out. Or alternatively, as you can see, we can opt to create a login form authenticator. So let's choose option 1 for the login form authenticator. Let's name our guard authenticator login form authenticator. Our login form root, and logout root for that matter, will need a controller. Security controller seems to be an alright name, so let's stick with that. The command has detected that we've already created our user class. It found it and it's offering to use it as the user class to authenticate, and that's great, we'll go with that. And finally, yes, let's have the command create the logout root for us. Super, let's see what we have. Firstly, let's check the changes to the security configuration in security.yaml. Here we see the command has added a guard authenticator to our main application firewall, the login form authenticator that we asked it to create, and also a logout path. Let's take a brief look at the security controller. We can see that it handles both login and logout routes. We won't worry too much about the code here, and there's no changes that we need to make. Now the command also created a login form template for us, so let's take a quick look at that. As you can see, it's pretty basic. We can see that it has added the CSRF protection to our form, so that's good. And finally, let's take a look at our login form authenticator. Now this is the class that would have been created for us if we'd chosen to create an empty authenticator, but none of the method bodies would have been filled in for us. We would have had to write all of this code ourselves. So Thanks, Maker Bundle. There's just one thing I want to draw your attention to at this point, and that's the on authentication success method. This is where the application should redirect the user when they are successfully authenticated. Now, the target path here is a feature where if the user visits a protected resource, such as the dashboard, we know they'll get a 401 response. We saw that earlier. Well, now that we have a means to authenticate, they'll instead be redirected to the login form, and Symfony will make a note of the original resource they requested, the target path, and it will redirect them onto that URL if they're able to authenticate successfully. We can also provide a fallback. In other words, in cases where the user lands directly on the login form, we want them to be redirected to the dashboard when they successfully authenticate. Now, we can redirect to any named route. If we have a look back in our dashboard controller, we can see that the route is named dashboard. So let's do that. Let's redirect to the dashboard. Here's the code. Return new redirect response. This URL generator generate dashboard. Now, with all of that in place, we're in a position to test our login form. So let's go back to our browser and attempt to browse to /dashboard, and we should get redirected to our wonderful login form. And we do. Now, I'm going to test it by putting in alice@example.com and any old password, and we get the message informing us that we've entered invalid credentials. We know that the right username is chris@example.com and let me in is the password. So let's try it with those credentials, and with any luck, if we've done everything correctly, we should see the dashboard page, and we do. What a relief. Well, let's wrap things up for this episode. We've done quite a lot today, and in the next episode we'll look at getting a database installed and switching out our user provider to load users from the database. I hope this episode has been useful. Thank you for watching, and see you next time.